So today we are going to enter the new chapter for this semester, which is Chapter 2, Atomic Structure. The first subtopic, 2.1, Bohr's Atomic Model. So Bohr's atomic model was proposed by Niels Bohr, which is a physicist from Denmark, around 1913. It was the modification of Rutherford's model. The limitation of Rutherford's model is that it says nothing about how the electrons are distributed around the nucleus and what are the energies of these electrons. So, Niels Bohr presented this model of the atom based on four fundamental postulates. So, let's have a look at the four postulates. The first postulate states that electrons move around the nucleus in a fixed circular orbit. Okay, if you look at here, the red dot here represents the nucleus and the blue circle here is the orbit, and you can see that the black dot represents the electrons move around the nucleus in this fixed circular orbit. The second postulate, electron at certain energy level has certain amount of energy. If you look at here, the electron at the first energy level n equals to 1 has energy negative 2.18 times 10 to the power of negative 18 joules, while the electron at the fourth energy level n is equals to 4 has energy negative 1.36 times 10 to the power of negative 19 joules. When the electrons move around the nucleus in this orbit at stationary state, it will not absorb or radiate energy. So the energy of the electrons is still the same. We are going to calculate the energy of the electrons at each levels by using this formula. En is equals to negative RH times 1 over n squared, where E is the energy, n is the energy level, RH is the Rydberg constant, which is 2.18 times 10 to the power of minus 18, and n here also represents the energy level. If the electrons make a transition, it will release or absorb energy. For example, the electron at the first energy level, if it jumps to a lower energy level, it will release energy. While when the electrons at a lower energy level goes to higher energy level, it will absorb energy. The difference in energy can be calculated by using this formula. Delta E is equals to RH times 1 over n initial square minus 1 over n final square. If the energy is being released, you can have the negative sign value here. While if the energy is absorbed, you will have a positive sign here. Or you can find the difference in energy by using the formula delta E is equals to h nu, where nu is the frequency. H is the Planck constant, which is 6.256 times 10 to the power of minus 34 joules second. We know that nu is equals to C over lambda. So, we also can calculate the difference in energy by using this formula. Delta E is equals to hc over lambda, where c is the speed of light 3.0 times 10 to the power of 8 meter per second.